Hello, anatomy class. I'm out today, obviously. Uh, I do want to keep plowing through our material because there may or may not be a snow day later this week, and I want to try to get our uh, larynx and lung dissection in this week, so I don't want to push things back too far. We are going to walk through a bit more of respiration. We're going to talk about cellular respiration, internal respiration, and we're also going to talk just a little bit more about those lung sounds that we heard last week, just to kind of give us a little bit more feel for what those were, what those are, and what motivates our breathing. So, just like we were in class, you should be taking notes, but I'm not going to grade it. This will be our kind of lecture for today. So after you're done with it, you can work on the workbook, same as we normally do in class. So, our respiratory gas movements are always reflexes or voluntary reactions. That's kind of every way you can move a muscle, though. So, let's kind of walk through them. This is a summary of them. Coughing and sneezing, these are usually reflex, and they are done to clear the lungs, to get stuff out of the lungs, or even the trachea of debris. Crying and laughing are emotional responses, but they have a specific breathing pattern, usually a bigger inhalation, a large inspiration followed by short bursts of expiration. A hiccup is usually just a sudden inspiration, and then a yawn is a really, really big inspiration. It will clear all the, ventilate all the alveoli as well. If you want to look at all of them a little bit more in depth, hit pause and read this slide. So the respiratory sounds we monitored last week using the stethoscopes, you should have heard a couple of different things. I think we all heard the bronchial sounds, kind of the air whooshing sound, or like soft leaves kind of blowing in the wind. This was the large passageways, the trachea, the bronchi. Some of us, I think, heard the vesicular breathing based on what you guys described, which is the alveoli. It's a little harder to hear, and I was kind of just hoping we'd get there, but if you didn't, it was kind of that tail end sound that was after the air, like wind almost. Here is those points that we saw on the person in the video. I found this to be helpful to kind of look at where each point would show us different things. A lot of people had pretty good results with the vesicular location over the whole lungs and the bottom of the lungs to get that soft, low pitch. Some people, I think, did hear the bronchial sounds. And we didn't really look at tracheal. It's just on the picture I stole off the internet. Right. So, after breathing occurs, we got to get that oxygen to tissues. Right. That is going to be gas transport, and then using that oxygen in the tissues and getting carbon dioxide out of the tissues is internal respiration. You can always remember that gases move from areas of high concentration to low concentration because this is just diffusion. The only active part is moving the blood and moving the lungs. Gas moves passively. So, external respiration is in the lungs. This is getting oxygen into the blood. We use that term loaded, right? Oxygen is loaded into the blood. You could think of like putting things in your car, loading things into a truck, that kind of thing, to help you remember. But the pulmonary capillaries, so the capillaries in the lungs gain oxygen here, and then carbon dioxide is unloaded out of the blood. So the carbon dioxide concentration in the pulmonary capillaries is decreasing, which means your lungs should be having blood leaving them, going into the heart to go throughout the body with a whole bunch of oxygen and not very much carbon dioxide. There will still be some carbon dioxide, but not as much. Right? And you can see that in this picture. the grayish blue and red arrows here. Bicarbonate ions and carbonic acid are one of the ways that our bodies kind of handle the extra carbon and carbon dioxide from CO2 as well as gaseous CO2. Right, in the blood, oxygen is transported via hemoglobin, which we abbreviate like this, capital H, lowercase b. It is not an element. It just has a abbreviation, a symbol, because it is a macro molecule, quite large, and it kind of holds oxygen in place as it goes through the plasma. Right? It does kind of look like this filled-in donut shape, the torus. Carbon dioxide, like I said, is transported in that bicarbonate ion and as a gas. But it also is inside the hemoglobin itself, just at different binding sites. You'll remember binding sites when we talked about proteins and enzymes having active sites, which is where the molecules actually like fit together. Or when we talked about smell and the chemoreceptors having specific binding sites for different chemicals, this works the same way. All right. So for carbon dioxide, we need to get it out of the blood and into the alveoli, which means that bicarbonate needs to be broken down. Right? We do that by combining it with hydrogen atoms. Hydrogen ions. They're missing an electron to form carbonic acid, H2CO3, which splits to form water and carbon dioxide readily. It happens spontaneously. There's no need for energy to be added there, and it's just seeking that more stable state. But once it does, the carbon dioxide diffuses from the blood into the alveoli, as gases don't want to kind of stick around inside the blood. They want to escape to a lower pressure system, which is the lungs. Again, we can see that system here, just kind of checking in. We're now on the right side. We talked about the unloading of CO2. Internal respiration happens at the tissues, right? It's just the exact opposite of what's happening in the lungs. So if you've got what happened in the lung memorized, you could just flip it and you're good to go. Carbon dioxide is going out of the tissues to blood. So carbon dioxide is being loaded to the blood, and oxygen is going from blood to tissue, so it's unloading oxygen. Right? And again, this looks very, very similar because it's the same thing. So we swapped the lungs in the top half of this diagram for tissue cells. Everything else is exactly the same. The mechanisms are the same. Everything is the same. Just swap tissues for lungs and what's being loaded and unloaded. Right. Didn't want to put too much on our plates today. We should wrap up the unit tomorrow. So today, workbook 7.4, page 271 in the workbook should be number 18, 19, and 20. As usual, any images you can just label. Try to get as much of it done as possible. If you've got questions, shoot me an email. I'll check it probably this afternoon or tomorrow morning and get back to you. And keep up with the workbooks that are due today and tomorrow as well. I will see you guys when I return.